All right, STEM chemistry, sorry about that. I thought it would be best if I come back and at least finish this problem up and then I'll just do the next one. I hate to leave it. It would just be so bad. Okay, so where we left off on the last one was oh, I can't reset, that's right. Let's see, we were solving for molality. So we take this right here. We had 0.01431 moles of sucrose. And we were dividing that by 0.175 kilograms of water. Because to get molality, we would do moles of solute over kilograms of solvent. And so when we do that, we end up with a molality of 0.082 molal is what they say. Molal. Yeah, I know it sounds weird. Okay, so molality is equal to this. Here's our molality, here's our Kb, here's our Van Hoff. So we've got to find our change in boiling point temperature. And we do that by multiplying our Van Hoff, which is 1, times our Kb value, which would be 0.51 degrees Celsius times kilograms per mole. And we multiply that by our molality, which is 0.082. And molality is moles per kilogram. Okay, and I'm going to do it this way so you can see how the units will cancel. All right, so kilograms cancel with kilograms, moles cancel with moles. The Van Hoff factor is a factor, it's a ratio, it's not, there's no unit, so we don't have to worry about it. So what we have to do is solve, and we're left with our answer in degrees Celsius. So we know that degrees Celsius is our answer, and now we plug into the calculator 1 times 0.51 times 0.082, and the calculator gives us 0.0417 degrees Celsius. Now, if you stop here and say, oh, the boiling point is that, well, you're wrong. Okay, we don't. This is just the change in temperature for our boiling point. So we've got to do one more step. Now, what's the normal boiling point of water? The normal boiling point of water, that's what I'm going to write there, is 100 degrees Celsius. But we're raising it, remember, we're changing it by 0.0417, so we've got to add that in. And our new boiling point is 100.0417 degrees Celsius. Now, there's our answer. Some of you might say, well, whoopity-doo, you went up by 0.0417 degrees Celsius. But you know what? That's a huge difference for some substances. It is a huge temperature difference. Okay, maybe not on the grand scheme of things, but that's a big temperature difference. So don't downplay it. All right, example number 2 says calculate the freezing point. Ooh, we're looking for freezing point now. Yay. For water, if 320 grams of solid calcium carbonate is added to 2,500 milliliters of water. Okay, so we've got to find our delta T. We need our I, we need our Kf, and we need our molality. All right, so our I value we get from our dissociation of calcium nitrate. All right, so calcium nitrate, CaNO3 it does become aqueous when it's put into water. Remember your solubility rules. All right, so it's going to break apart into calcium ions, and it's going to give us 2 nitrate ions. Okay, so 1 plus 2 gives us 3. That's our Van Hoff factor. Our Kf value we get from our chart. So we need our Kf value of water. So let's go back to our chart. Our Kf value for water is 1.86 degrees Celsius. Okay, so let's put that here. Kf is 1.86 is what I said. Let's see, I've got it written down. Yep. Degrees Celsius times kilograms divided by moles. Okay, now we need our molality. All right, molality, remember, molality is equal to moles of solute over kilograms of solvent. Okay, so moles of solute, that's where we take the 3,200, or 3,200, that's not, 320 grams of solid calcium nitrate. So 320 grams of calcium nitrate, and we change it to moles. All right, 1 mole. And the formula mass of this monstrosity is 164.1. I've already got it, so we'll just keep going. All right, so plug that into the calculator, and it should give you something around 1.950 moles of calcium nitrate. Remember, that's our solute, and we need to put that over kilograms of solvent. Okay, so now our solvent is water. And we know that we have 2,500 milliliters of water. And you're like, Mr. Ark, it's in milliliters. We need kilograms. Okay, well, you can use density. Density, it's a wonderful thing. Because density is grams per milliliter. And density will allow you to change from mass to volume and volume to mass as long as you know the density. Well, the nice thing about water is the density of water is 1.0 grams per milliliter. That's a beautiful thing, isn't it? Okay, so if we want to get rid of this, so we put 1.0 grams over 1 milliliter, and those cancel, and 2,500 times 1 is 2,500, right? Yay! Okay, and then we need to go from grams to kilograms. So 1,000 grams is equal to, 1 kilogram, and that would give us 2.5 kilograms of water, right? Good, 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 good. 2.5, let's, 2.5 kilograms of water. Okay, so when we plug that into the calculator, 1.950 divided by 2.50, or 2.5, is equal to 0.78 molal. Okay, now that's not our answer. Remember, that's just our molarity. That's just this. Okay, so now we've got to plug all that into delta TF KB, or nope, this is KF, my bad, times I times M. Okay, so KF we said was 1.86 degrees Celsius times kilograms over moles. I is 3 and M is 0.78. Now you can put an M here, but I'm going to put moles per kilogram so I know that my units cancel. Okay, there we go. And then we plug it into the calculator. And the calculator gives us this wonderful number, 4.352 degrees Celsius. Now, is that our new freezing point? If you say yes, you are going to be in big trouble. Okay, why? Because that's the change in temperature. All right, what does water freeze at? Well, water freezes at 0 degrees Celsius. And remember, we're making it go down. We want the freezing point to go down. So are we going to add this or subtract it? We're going to subtract it. Oops, I wrote the wrong number. So 0 minus 4.352 degrees Celsius gives us a negative 4.352 degrees Celsius freezing point. That's a big difference, especially compared to the last one, right? Okay, so now you have an idea as to how to use these. I promise we're not going more in depth than that. We're going to stop right around there, okay? And I love this one, so I just thought I'd add this in there, and I will see you in class.